This is section 5.2, logarithmic functions. So here, these two are ways we convert between log, this is log form, and this is exponential. There's also one for if your base is E. So y equals natural log of x is the log form. The exponential form is x is equal to e to the y. E is the base of the natural logarithm. So some of these, they just want you to go between the two forms. Remember, if they have uppercase, you need to use uppercase. If they have lowercase, you need to keep it lowercase. Math does see those as two different variables, an uppercase and a lowercase. We want to write this. This is a log. They want you to write it as an equation involving an exponent. So the way I remember it, and you could always look up other ways, log equals the exponent. So my exponent is the capital D. 7 is, it's a subscript. It's down here. It's not like up here right next to the log. So that's the base. It's at the bottom. So the base is 7. And the thing that's left over, it's called the argument. We use D, we use 7, so we just have the C left over. That's the argument. So the base is 7, the exponent is D. Okay, this is your base. This is your exponent. This is your argument. This is your exponent. B is your base. X is your argument. So your base is 7, your exponent is D. So what we have left is the argument, which is C. It just takes a few times to go through this. This one, we need to change the exponential statement to one involving a logarithm. So our base is at the bottom. The base always has the exponents. Our base is 6. Our exponent, that's pretty easy to find, is a 2. So what we have left over is our argument is 36. So log base 6, log is equal to the exponent. Okay, so log base 6 of 36. Now in the homework, and you can just type in log, it'll recognize it as log, but you'll have the little subscript button down here. Again, anything you need will pop up down there at the bottom, but you'll have a little button to put this guy in. All right, this one is in log form, but it's a natural log. All right, so log is equal to the exponent. So the exponent is y. The exponent is on the opposite side of the log. The base of natural log is e. You don't see it there. And then the argument, what's left over, is the 15x. Our base is e, and the base always has the exponent. So that's e to the y. And that's going to be equal to what's left over, the argument, which is 15x. We need to write this exponential equation in logarithmic form. So our base is 11. The base has the exponent on it, so our exponent is y. What we have left over is our argument, which is x. So it's log base 11. Log is equal to the exponent. And the argument is what is left over. All right, so here our exponent is 4. The exponent is always on the base. So our base is 3. What we have left over is our argument, and that is the 8. All right, so log base 3 of our argument is equal to the exponent. So log is equal to the exponent. All right, we need to evaluate these. We're going to use the calculator. It does have a button. So let's see, where's the log? The log is right above the 10 to the x. So control log. Now this one doesn't have a base, so you can just scoot over, and I'm going to type in 6. When you hit enter, it's going to put a base of 10, which is fine. If there's no base on the log, the log, it's understood to be 10. The one that's ln is understood to have a base of 8. Okay, so we want 3 decimal places, 0.778. Another way to think about this is 10 to the what power, it's going to give you 6. It's going to be the 0.778. No, it's not. It's going to be close. It's going to be close to 6. The more decimals we take out on the exponent, 8. That's going to get it closer to 6. But that's what we're finding, those weird exponents. The natural log is above the e to the x, so control e to the x, and we need the natural log of 45. Again, they want 3 decimal places, so it's 3.807. This one doesn't have a base. It's understood to be 10. And you can type the 10 in if you want, or you can just ignore it. 4.674. Please make sure you read on the homework, especially on the test, how many decimal places they want. These tell you to evaluate the logarithms without the calculator, but we're going to go ahead and use the calculator since we have it. And you may be able to see some of these are pretty straightforward. So 5 to the what power? 5 with what exponent gives you 25? So control log. This one does have a base. You see how it's typed in? You hit enter, and that's going to be 2. So 2 to the 5 to the second power gives us 25. All right, this one has a base of 7. So 7 to the what power gives us 343. That's 7 to the third power. And then 10 to the what power gives us 100. And that's going to be a 2. All right, this one you can put straight in your calculator. There is not a base here. If there was a base, it would be lower down. Okay. So we're not going to go over all the properties of logarithms. There's quite a few. I think they're fun. But, all right, so we have a regular log that's 10 raised to the 15th power. It'll put that base in for you. That's fine. That's going to give you a 15. Okay. If you want to see the property, I can show you what this is. With logarithms, you can pull the exponents out front. This understood base is 10. If the base and the argument are the same, that's the same as 1. That's how they're getting that. Right, and then these over here are some special cases. So 2 to the what power gives you 1? Okay, 0. Anything to the 0 power, you may or may not remember this, gives you 1. Okay. So that's why that one is going to be 0. The natural log of e to the 5th. So let's put that in. Again, the e is not a base, and it's the natural log. And then I typed the e to the x, and it was, what was the number? 225. Gives us 5. What happens with that one? Again, the exponent can come out front. The base of the natural log is e, so if the base and the argument are the same, that's just 1. So it's 5 times 1, which is 5. All right, and the log of 0.01. Again, there is no base indicated there. You can put the 10 in or you can leave it. We get -2. So if you take 10 and you raise it to a power of -2, you get 1/100. Let me convert this, which is 0.01. So you can just put that in. On the basis of data for the years 1915 through 1995, the expected lifespan of people in the country can be modeled by this function. So they give you the equation, which is nice, where x is the number of years from 1905 to the person's birth year. What does this model estimate the lifespan to be for people born in 1980? Okay, so we have 1980. What x value is that? That would be 1980 minus 1905. So you're going to plug in 75 into the equation. All right, the parentheses are very important. They need to stop, they need to close around the 75. It makes a difference. It will affect the answer. It won't be anywhere close to what it needs to be if you don't have those parentheses in the correct place. All right, natural. I'm going to go outside. And if we round that, their life expectancy is about 71 years. Suppose the supply of a product is given by this equation, where P is the price per unit and Q is the number of units supplied. What price will give a supply of 6,200 units? So 6,200 is our what? That is our Q. So we're going to plug that in. Exactly like that. Those parentheses are around everything, just like the original equation. So $58.28. All right, we have a Richter scale measurement for an island earthquake of 2007 was 5.5. Find the intensity of this earthquake as a multiple of I naught. All right, so the Richter scale rating was 5.5. If you go through view the example, they have an overcomplicated equation. Basically, your Richter scale is the log of your intensity. Okay, so we have 5.5, and I'm just going to put the log of x. It'll be easier that way. So let's go over here. Let's do numerical solve. Log understood base 10. Now make sure your arrow outside the x, outside the parentheses, put comma x. And this is going to be a whole number, so 316,228. So the intensity is 316,228. Again, go back and maybe make notes on there on how exactly it looks in the calculator. All right, so if an earthquake has an intensity of 89,000 times I naught, what is the magnitude, which is the Richter scale? So we need the log of 89,000. So let's go. And we just need to put the right side. We don't actually have to solve. 1, 2, 3. You can put the 10 in on for the base. So the Richter scale is going to be 4.9. This is just going to be one decimal place. Again, they have an overcomplicated formula. This is a more, I guess, basic formula. Government considers a single person is living in poverty if his or her income falls below the official poverty level, which is adjusted every year for inflation. So the model is for the years from 1987 to 2008. So here's the equation, where X is the number of years after 1980. So what does this model give as the poverty threshold for the years 2015 and 2020? So what X do you use for 2015? So how many years after 1980 is 2015? So do 2015 minus 1980. So that's going to be 35. And then the difference between 2020 and 1980 is 40. So those are the values we're going to plug in. And these are going to be the nearest whole dollar. $11,580. Let's see for the second one. It's 12,136. So from 2015 to 2020, the income threshold was increasing. It went up, so it's increasing. And then we're going to graph this, and it says X5 to X40. If I remember correctly, it's multiple choice. So our highest was 12,000. I'm just going to put 15,000. I don't remember. They may have just 13 or 14,000. All right, so here, and I'm going to tell you where the problem is. You need to make sure you put the X in. A lot of students forget to put the X in. They put a number in when they're graphing it. Put in the X. Okay. So this is going to be your X min. This is going to be your X max. This will be your Y min. And this will be your Y max. Again, this is going to be multiple choice on the homework, but you need to have your windows set correctly. So look at their windows under the bottom, be 5 and 40. So let's go. Let's go ahead and change the window first. If you graph it, you're not going to be able to see it until you change the window. Oh, we did 15,000. Right here, students mess up. Do not put a number in those parentheses. You need to have an X. If you put a number, you're just going to get a straight line. Okay, and then that is the graph. So down here, it's about a third of the way from the bottom, and it goes out about 2/3 of the way up, and it is a curve. And that is it for section 5.2.